I think we can slowly start. Good afternoon, everyone. Welcome to our panel discussion about observability. I think you noticed that the observability is nowadays a big topic also within this conference. So many talks on it, and I'm really like that I can be here today with all the experts who had also talks or help us with the organization, be part of this panel. And before we start, we would like to ask you a few questions maybe. So how many of you are here developers? Just raise your hand. Okay, so most of the people. Do we have any SRE? Okay, so 4 maybe. And how many of you are very new to the observability topic? Okay, perfect. And do we have many people who are working on daily basis on observability? Okay. Thank you. So I guess we have a nice crowd here. And before we start, please don't be shy to ask questions. We have a Slido, so I will try to check it, but put questions there, and we will get back to them at the end of the panel. And you can also ask questions if you want to speak up, okay? Now I would like to give a word to our speakers and introduce themselves a bit and tell us why they are part of this panel. So maybe, Miro, we can start with you.
Okay. I'm Miro Adamy. I work for a company Pivot3, which you probably never heard about. It's a Canadian company. I work for the Spanish office for the European office, which is in Spain, of the company. We do many things, and I particularly work in the infrastructure and cloud department. I'm sort of like DevOps/SRE role. You can find us on the web at pivot3.com, and there are people that explain much better than I would what we do. The reason why I'm on this panel, because my good friend asked me to, and he believes that I have something relevant to say, which is something that I'm not 100% convinced of, but well, I'm here.
Hi, I'm Zdeněk, Váňa. I'm working for Prussia Research as a cloud and DevOps team lead. And in my free time, I'm organizing the community in the Prague. I'm in the Cloud Native Prague meetups and also this event. So maybe it's the reason why I'm here. Because one of my responsibilities is also the observability stack. So that's it.
Hi everyone, I'm Goutham. I work at Grafana Labs, but I started off as a Prometheus maintainer like 6 years ago, worked on the storage engine and on the general Prometheus maintenance for a while, and then on Loki, Tempo, and quite recently on OpenTelemetry. But nowadays I'm doing rough screens because I am a new product manager, but I still am super plugged into the observability side of things. So yeah, that's why I'm here.
You went to the dark side. Hello, my name is Eric Schabell. I'm Director of Technical Marketing and Developer Advocacy at Chronosphere. It's a cloud-native observability platform. Yeah, and I think that fits pretty good with this panel, right? So, looking forward.
Thank you, Eric. Hello, I'm Petr Stýblo. I work for IBM as technical pre-sales. I've been working for observability recently, but I spent almost all my career life working for monitoring. So maybe we get to the distinction, what is the difference between monitoring and observability. Why I'm here? Well, that's exactly the reason. Thank you.
Thank you, all of you. So as you can see, like we have a really group of people who are part of different companies. So maybe the term observability can be different. And also like we have people in the audience who are new to it. So can some of you maybe give us some ground about what observability means and how it fits into the Kubernetes world? So we have like common ground for the discussion. Who would like to start?
I'll do the academic part. There's actually a definition here. So if you can look it up, I did that too. So it's not from the top of my head, but actually observability is defined in some way. I think it has been defined ex post after we have started using observability and people trying to find the right meaning. So that's my impression. But anyway, observability as a term, it's an ability to define or to come up with some insights or knowledge of a system, of a distributed application or cloud native application by analyzing the external outputs, external data, by means of some signals, right? And everybody has heard it many times over the last 2 days. There are some defined signals that we commonly agreed on, traces, metrics, logs, but there's also many other signals that have not made it to the observability definition. So those are less pronounced, such as profiles. There's also events. This is where I come from, event management. So event is not a log message. And there are some people that consider it also errors. I mean,
aggregation of errors.
Errors, when you're catching exceptions. Thanks for that. And there's actually a definition by the founder of Jaeger, Yuri Shura, who defined the term temple. So traces, exceptions, metrics, profiles, logs, and events. Did I say events yet? And anyway, pass it on.
Thank you, Petr.
Okay. When you look at observability, I like to look at it across the generations of what's been going on in the monitoring spaces. Originally, we started out with server racks, data centers, and you were actually monitoring what a known environment, a known size, very very easy to target application layers and all this different stuff that you were doing, whether it's a system or not. You went to the second generation, you started getting VMs, and it gets a little bit more complicated. That's kind of when you saw everything you're seeing now around APM and those kind of monitoring platforms, looking at applications and stacks and messaging layers and things like that. And then you have the cloud native world where things are auto-scaling with Kubernetes and the data explosions that you're going to hear us talk about here today. And that requires a third generation of monitoring and observability. And that's what the cloud native observability platforms are that you're talking and hearing about today. They have to give the customers the ability to control the speed with which things are happening, the cost that's being generated, and give them insights into the data that they're using and not using to be able to deal with these environments, to survive in these environments, especially when you get successful and it all explodes in your face.
Yeah, I mean, you two answered it pretty concretely. I don't think I have anything extra to add. However...
Sorry about that.
No, it's a good problem to have. I have a lot of non-technical friends who call me up when their volume stops working in Windows, and I tell them to restart, and they ask me, what do you do? And I'm not going to show them graphs. But like I kind of explain that, I kind of help people understand what their code is doing, and this could be any code, and it could be any form of understanding. For example, people say logs, metrics, traces, but just errors and error aggregation is good enough, and it's observability. So yeah, anything that helps you understand the piece of code that you're writing is observability.
Mm-hmm.
I think that we have more types of the observability tools. So when I should somehow describe to my child what the observability is, so I just mentioned that you have the application when it should run in somewhere. So you should know how the application is behaving. Yeah. the behavior of the application, and not only the app, but also about the platform, about the network. So I have to collect some data about it. And also I like to somehow make some visualization of this data and also make some alert solution that I wanted to know that something is, I see different behavior of the trends in these metrics or logs. So it's just about the tools for getting these, we can call it metrics, and the way how we can store it there somewhere and how we can make some decision from them.
And Miro, do you want to add something? Or?
Well, only maybe two things that has been described pretty thoroughly, and I don't really have to add too much to it. There's one aspect that wasn't mentioned is that when you talk about observability, it's not only about the tools, because at the end there is some kind of notification. There is a Ops Genie notification there, or PagerDuty, or a Slack message, or something, whatever you have. But there's also important, what do you do as a result? So there is this process part and the human part of the observability. At the end, the goal of the observability is an action. That doesn't make sense to get information which you don't act upon, most of the cases. And this is also important part of the observability. That's one comment that I would like to add. And maybe the other kind of comment is that equally important is what, in addition to the things that happened, are the things that don't happen. And that's a sign. This is something that usually happens, doesn't happen. It's this anecdote of the dog that was not barking, and then that was the clue in some detective story. And if you have data about your system, if you collect data over a period of time, you will get very valuable information, and based on this data, you can go into the path and see which things are supposed to be happening and are not, and that's important. And also, what are the trends? We work in the e-commerce space, and for us, the Black Friday time is very important time. And what we usually tend to do is to look at the metrics from the last year and see the trends and anticipate the load and make sure that we can meet the load or more for our clients. That this is also a side effect of the observability, learning from the data, not only directly acting on the data, but acting on the data in kind of a larger time horizon.
Thank you, Miro. You touched maybe on the next question a bit, because like for me, it's easier to understand when I hear some practical examples of how DevOps teams or SRE teams or whatever you call it nowadays use it. So can you give me some more practical examples of observability and how it is used?
Well, we use pretty much the standard tools. Then we use Prometheus on Kubernetes, we use Grafana, but we also still have some data centers from the past, which we are in process of migrating to cloud. And therefore, we inherited our own share of some older tools, and it's kind of challenging to streamline those data and make sure that the same process of handling these notifications can be used when it comes to a cloud and the data center, because usually you have different teams involved and different kind of skill set required for dealing with it. So I don't think that my particular experience is very typical for if you are really living in the cloud, then the practical example is, well, pick something that is well aligned to your organizational structure, because you don't want to just install Prometheus that will generate like lots and lots of information, lots of alerts. You need also to define which of these are important and how are you going to handle them. What are you going to do as a result of these things? If you don't define that and if you don't clearly separate important things from unimportant things, you may not get the results that are expected, because the really important information will get drowned in the noise of those monitoring system can tell you a lot, and they can sometimes tell you too much, and it's equally important as making sure you pick the important events is not to pick the events that are, for example, in Kubernetes, there are a lot of things that are self-healing. And you want to know about them, but you don't want to start a relatively expensive process of notifying and raising people during off hours just for something that you know from history that will correct within like 2 minutes or 1 minute. If it's still within the SLA, that's perfectly okay. If it doesn't fix, then you want to start the whole process. So that's...
Thank you. Eric?
Let's change the order up a little bit. Instead of talking about technology so much, which tends to get us all down into the weeds, basically what you're looking at with one of these use cases is you want to know what's going on as fast as possible. You prefer to be warned before it happens, but okay, maybe it happens and then you get warned, but you know as quickly as possible. You're not waiting for your visualization to load because there's so much back data and stuff piled up that you can't get your images in front of your face. You want to be able to triage this stuff as quickly as possible, whether that means remediate or whatever it's going to be. You want to be able to take action and take sensible action. And you want to be able to go back and understand really deeply what happened so it doesn't happen again. You can take measures. So we talk about know, triage, and understand. That's not logs, metrics, tracing. That's not digging down into Kubernetes pods and all this other kind of stuff. It doesn't matter where it came from, where that information presented itself, as long as you're able to corral it and use the information that's important to you to make decisions, and you're only paying for what you're using, then you're going to be a happy camper and you're going to have a really effective observability stack. It's something that people are struggling massively with in the cloud to achieve.
Yep. For a practical example, how many of you have seen the architecture of Cortex or Mimir? Okay, it's like 9 or 10 different microservices. So I joined Grafana right after college, and I was supposed to do query optimizations on this massive beast, and I had no clue how everything worked together. And of course, I was working with the creator of Cortex at that point, so he used to hypothesize in his mind, and then he used to explain to me the hypothesis, and then he used to run the experiment, and I'm like, what the hell are you talking about? So I took some time to set up Jaeger and tracing, and that changed the whole view for me. For example, I could look at a slow query, get the trace ID, look at the trace, and I could understand, okay, it took 18 seconds because PromQL took 3 seconds. Because talking to S3 or Bigtable took 5 seconds. So it kind of helped me understand what was slow. I mean, I still couldn't optimize shit, but at least I understood what was slow and why things are working the way they are. What are all these components and how they work together. Yeah, so that's one practical example of observability for me as a new developer trying to understand a beast.
Okay, I can give you some examples of usage. So we can split it up to two things. One is the platform, and the second one is the app itself. So when we speak about the platform, so I'd like to get some, I'm running the Kubernetes cluster. So I wanted to get some metrics. So I can use, for example, Node Exporter to get some metrics to the Prometheus. And then I also wanted to get some events and logs for the platform itself. And when we move to the application, so when I run the application, so I like to have some the application metrics. Like, for example, I wanted to know how many users are connected to my website, right? I also wanted to collect some logs. So I can use a solution like Loki, for example, or ElkStack to get the logs. Yeah, but there's also the second type of the logs, and there's the exceptions, right? So you wanted to know once there's something strange. So you can use solutions like, for example, Sentry to get these metrics and see some trends and set some alerts about it. Yeah. But when your application, sometimes there is no issue, I mean, from the logs perspective, but you can see that your application is slowing down. Yeah. So you wanted to know what's happening there. So the thing is that you like to get some traces. I mean, the analysis of the whole flow what happens when you call, for example, exact endpoint. So you should have some tools like Jagger or Tempo to collect these metrics, but you have to also make them together. Yeah, because if you have only one of the type of these events, so it's useless. So you have to somehow make some visualization, for example, via Grafana, and then you have to set some alerting, and then you can use, for example, the alert manager from the Prometheus stack. But the last thing is that for these all solutions, you have to use a different tool, and it's quite common that you store it in different tools. So maybe you should realize that you'd like to have also high availability mode, and also some one store for all of these types. Yeah, because if we speak about the metrics and the Prometheus, so you can use tools like Thanos for the high availability mode. Yeah, but sometimes you have more data sources and you wanted to collect them. Yeah, and for these cases, the Thanos is not good enough. So maybe you can look about the other tools like Mimir, for example. So yeah, there are so many tools, so I think that it's quite hard for guys to choose the right one.
Yes, Zdeněk, you ended the question right away because I wanted to ask about this. So you all mentioned different tools within the CNCF landscape. There is thousands of them, and it's so difficult to figure out which to use. And maybe Eric mentioned that sometimes the technology is not something that you should put like front when you are implementing it. So what criteria the people should have when they are thinking about implementing it?
Happy to start that one. So one of the interesting things you're going to find out...
Sorry to interrupt you. I have one, I just look at the question and there is a follow-up question on this. How do you balance it between gaining observability and maintaining performance in Kubernetes? So that can be also mixed with that question. So, sorry, Eric.
What's the question again? Can I read it somewhere? The first one? What do you think about... Third. How do you balance between gaining observability and maintaining performance in Kubernetes?
Yeah. And Eric, you wanted...
So is that...
I didn't want to interrupt you. It's just that Eric, continue in the...
Okay, let me try. I know I'll give it a try. If it's wrong, somebody else will take over. But my understanding, if the question is right, and whoever raised the question, feel free to correct me. But if you mean, like, is observability, like the tooling, the instrumentation, slowing down basically Kubernetes, making it less performant? Is the question about how do we make? I came online. Okay. So anyway, if that's the question, I think it has been already asked in some previous sessions. It's really a matter of choice, like what you want to observe, and we can think of it as from many angles. But one first angle would be, don't overdo it. Like, there is no observability that will get you everything from a single source or a collect-all agent. There may be some efforts to do that. Even mentioning open telemetry, the ambition is really huge, like to provide a solution for all. But it will never be the case because yes, you will kill the system just by observing it. So the right thing, I think the right approach, the reasonable approach, and this has been proved like in the history. You need to be selective at the beginning. What do you need? What are you interested to see? What's your business reason to do the observability? What are the outcomes that you want to get out of observability? And collect just the data that you need. Start low. Observe the system, how it performs. If you can do more, if you need more, raise your granularity and proceed gradually, simply. So otherwise, of course, there will not be, the observability itself. I mean, it can be a pretty intensive process. So be cautious on choosing the tooling and choosing the amount of data.
Miro?
If I may add, I would emphasize different aspect of that. It's not only performance. That performance is usually not a big deal. It's kind of a few percent of the whole output. It can get worse if you go overboard and try to post-process those things and aggregate and summarize and predict and do all kind of complicated processing on it. But the interesting things that I've noticed before we started to move towards the SaaS solution like Grafana is that if you install in an empty Kubernetes cluster all those best practices tools, all the Grafana, Prometheus, Jaeger, and so on, all the Fluent, Beat, and all those things, then you end up with like 15 pods that are just for that purpose itself. And these pods they're not a big deal from a performance perspective. They are fairly lightweight, but they quite often are responsible for a lot of more observability noise. Kind of the observability system is observing itself and reporting on itself a lot, which actually defeats the purpose. You want to be notified first about the business loads, not about that this pod from observability cannot talk to that other pod from observability, which is usually self-corrects itself. So this is the kind of weird effect of if you put a lot of tooling in place, that tooling will keep itself busy for a considerable amount of time.
One more comment is like performance. I know it has been related to Kubernetes, but you can make it more generic. The thinking, like the performance is not just the performance of the system itself, but you can think of business performance. You can think costs. Those are things that you need to take into consideration, especially with tracing. I'm sure this is the case with metrics. Costs of storage are becoming, a differentiator at some point. If you just go crazy and collect all the data, you need to put it somewhere. And of course, this relates to performance after all. Yeah, if you don't have the money to buy expensive storage, your performance will not be good.
I also think that's a reason you're seeing quite a bit of the larger users of these kind of platforms outsourcing this to a SaaS provider, which is what we also do together with Grafana Labs does the same thing. There's a real reason for this. We did an observability report in 2023, and I mentioned this in my talk yesterday. There were some statistics in there that were pretty shocking, and one of the biggest ones is that when you're setting up your infrastructure and running a DevOps kind of organization in the cloud and dealing with all this cloud-native complexity, and you start putting together your observability platform, and pretty soon that starts becoming not just a part-time job, but it becomes a full-time job. And your team starts spending more time not doing what they're supposed to be doing, but more time managing the infrastructure. And the SREs that put their hands up can tell you all about this. Becomes a full-time effort. And out of that research report, which I linked to in my presentation, if you want to go back and look at it, one of the most shocking things for me is 25% of their time, these engineers, is being spent on issues and triaging problems. So if you're spending, 10 hours a week doing this, are you happy? Is that what you signed up for? Is that really what you enjoy doing? And really quickly, you see when it gets to be a large-scale operation. One of our customers, for example, during the pandemic, DoorDash, delivery of food, right? So when everybody got locked down in the pandemic, they started delivering food like crazy. And this scaled up so fast and so hard that it became more than a full-time job, right? You need to outsource that kind of infrastructure and get back to doing your core business to make the money where you want to make it. And getting people off of 10 hours a week of triaging issues, and which leads to nothing more than a bunch of statistics about burnout and why people don't want to work there anymore. And this is not how you want to live your life. This is not how you want to retain your talent. And your talent you actually hired for something else, probably, right?
There was another interesting statistic in his talk. It's quite common that the cost of observability is more than the cost of infrastructure. So I have a question for you. How much do you think observability should cost? So if you're paying $1,000 for infrastructure, how much are you okay paying for observability? Is it $5? Is it $500? Is it $5,000? Yeah.
No.
In the end, it comes down to the business question. You first need to understand, okay, what are the questions I would like to ask, and how quickly do I need them answered? And some people would be like, I need to answer all the questions in a millisecond. And that comes with the business trade-off that this is going to be ridiculously expensive. So you need to kind of while choosing the tools, while choosing the providers and stuff, you need to understand, okay, I'm okay if I'm only able to answer these set of questions within 5 seconds, something like that. Like, it's okay if I see only 5% of my traces. And at that point, you'll be like, okay, 5% of traces cost me 50% of my observability toolset, and 50% of my infrastructure, and 1% of the traces cost me 10%. I'll probably go for 1%. Like, it's a business to value question when you're picking tools, and that's kind of how I would evaluate, like, do I really need eBPF profiles? Probably not. Would it be good to have? Definitely. Would I pay for them? No. And it's questions like this when you're picking tools. Yeah.
Okay, and are there any other challenges with implementing it or not? Like different observability tools?
Yes, there's always challenges. You could always be too good and write a bunch of alerts, and then your developers are getting paged all the time. That's a very, very common challenge. Too many alerts, and then you black hole all of them with an email filter, and then you sleep peacefully through the night. Your customers don't, but that's a different story. Yeah, the two challenges I see with implementing observability, three, I would say, is one, cost. The second one is too many alerts. That way alerts lose meaning. And the third challenge is not enough visibility, which means there are issues happening and you have no idea. How do you solve those? I don't know. If somebody can solve those, I think they will be really, really good at their job. Yeah.
Yep.
Just to add to that, the cost of storing data, it's important things, but especially with traces, there is this retention window that's kind of important. You don't really need traces except when you need them as a result of some event. It's like the rule that five hours before each fire, the fire department needs to inspect the state of those machines and so on. So essentially, you need to establish reasonable trade-off between the cost you are going to invest on an ongoing basis and how much you aggregate this information. There is one window where you want to keep the traces, all of them, for a certain amount of days, and that's after the new release. Because when you are releasing new version of the software, it doesn't have to be a problem with your software. It can be a problem with interaction with environment, with some hidden assumption. And in these cases, the traces are absolutely priceless. So this can mean days in terms of being able to react quickly and fix the issue. That's the.
There's a really practical example of what you might consider. It is a public case. I'm not going to mention the company name. You can go figure it out for yourself. But there was a CEO reporting his observability numbers and stuff at the end of the year, or at the end of the quarter. And it turns out one of the customers they had on this observability platform spent $65 million with them.
In 1 year.
In 1 year, right? $65 million. I mean, that should blow your mind, right? And it pretty much caught everybody's attention in the press corps too, right? So follow up and everything on that, and somebody just uncovered, I think it was last week, sent out the debug report on this, and it turns out it was a Bitcoin company. So that's like really rich people digging into their pocket, and what do they pull out? Is not the same amount of change I pull out of my pocket, right? And for them, 65 million at the time was definitely pocket change. You know, they were making oodles and oodles more than that, so they didn't really care. And that goes around back to what he was saying. observability costs, tooling, all the stuff you're using, nobody's going to care at all if you're making money, if customers are having good experience, if you're getting done what you want to get done, and everybody's able to discover where the problems are and fix them in time, right? We will pay anything. It's like Super Bowl ads. Why do people pay that much money for 30 seconds on TV? Because it achieves what they want to achieve. They don't care what it costs. The people that advertise it just don't care, right? They can afford that. This is the problem with when you look at this space, you can easily get just swamped with what happens in the bill, where it just surpasses everything you're doing normally in your business. But if that's acceptable to you, fine. Nobody's going to make a noise or make a problem out of this or change anything that they're doing. But as soon as you stop making enough money on this side, then this is going to become a huge problem, right? And that's going to be the first thing they start looking at. I mean, it's full stop. I think it was there was a pretty neat statistic last year, right towards the end, where I was watching a cloud report, and an analyst was talking about how in their research they found out that 83% of, I think it was 83%, maybe it's give or take a few percent, but it was in the 80s, organizations would have a financial operations, a FinOps position by the end of 2023. And that's pretty crazy, right? They can't figure out. The bottom line is basically your CIO, I think, owns, or your CTO owns the budget, right? That's the end responsibility for what you're doing with your platforms. The problem is you have developers sneaking stuff in, you have engineers sneaking stuff in, and nobody really knows who pushed that button in that cloud provider's marketplace to add this new load balancer that's now adding tags and metric cardinality that's just blowing up your budget, right? You need to have a position that fills that space, that quantifies what's going on, puts processes in place, all that kind of stuff. Apparently, within the next couple of months, everybody's going to have one in Europe anyway. So would you interested in that kind of a role, where you could be responsible for every penny that gets sent down the pipeline for observability?
Anybody?
Yeah, I see two big challenges. First is that you have to know why and what you wanted to collect. Yeah, because what I see in many companies that they collect a lot of data and they don't use most of them. I mean, never. Yeah. And the second thing is how long you wanted to store them. Yeah, because so many companies tries to keep their logs for almost a year. But just realize that last time when you look at the more than maybe 1 month older logs, yeah. So why are you storing them? So you pay so lot, and you have to find different tooling, because once you have these logs, so it's quite hard to find them because it takes time. So maybe the challenge is to find some agreement, I mean, with the developers and the management about it, what and why are you storing this data. Yeah. The second challenge is we have a lot of tools for, making the observability, but still it's quite hard to put that together. Yeah. So you can collect logs, metrics, traces, but there is no easy way how you can see on the one panel all these data, and you can easily to find the root cause of the issue. So yeah, there are some solutions like the OpenTelemetry, for example, right now, which tries to move the stuff like this, but we are not still there. And we have to find the solution for it.
And I will pick one question from the slide, because it might be related. Have you ever encountered something similar like happened to Datadog with massive outage? Can you blame observability or process behind them in such case?
My answer is happy no.
Anybody else? Yep.
So I think you're referring to the recent Datadog outage where they deployed Systemd, it broke Cilium, and that broke Datadog for quite a long time. Is that it?
CVE, I think,
Yeah. Can we blame observability? I hope not, because, but it's typically process, I would say. For example, in Kubernetes, we had a big outage where all our pods were suddenly being killed by Kubernetes, and nobody could figure out why for a long time. And it turns out we configured health checks, but we never activated the health check in the application. So Kubernetes was thinking this pod was unhealthy, and it was killing it regularly. Yeah, like we kind of weren't prepared for that. We didn't know what a health check was properly going to do, and we enabled it on all our applications. I would more call it a process and testing failure rather than blaming something like observability for it. And I think observability helped us fix it in the first place, yeah.
This is probably not going to age well, but right now I can say that Chronosphere has been able to keep 3 nines historically of uptime for the history of the company so far. That's not an easy thing to do. That requires quite a few things to happen, and you know, to be really good at what you're doing. I don't think it's fair to really pick on that specific outage, especially since the complete report hasn't been put out about the incident. You know, an incident. They put something out, but not all of it yet. So you kind of want to wait and find out exactly what happened. And I mean, those are the most interesting things to read, right? Because everybody can learn from those things. So we hope everybody's going to be open and honest about what happened. That's what you're looking for. And I think it's something seriously to evaluate when you look at companies that are providing these kind of services for you. How do they handle this stuff in the past? How open are they with you? Or do they just do that with select customers? You know, do you have to have a certain tier before you get good response times and things like that? I think that's super important. So I don't think it's fair to pick on a specific thing like that, and you can't just point to a specific cause or a specific reason, usually.
Just on that, of course, I don't have an example because I work for IBM. It doesn't happen to IBM. No, but seriously, I think this is referring to the point that we heard in the beginning. There's a lot of things that we don't learn, that we don't know from the press because of observability. You know, how many incidents have been avoided by thanks to having right tools, right processes, right observability in place. You will never hear the good news. This is actually no news. I mean, you will not hear it in the news, right? Nobody writes about things, but those are really the stories that we should hear. Like how many things they managed to avoid. This is a singleton. This is a disaster that happens to everybody. This will happen to everyone. And yeah, it's very sticky with the press.
Yeah. So I will pick up on some of the questions from the audience because they are really active, as you can see in the Slido. And there are 2 questions related to machine learning and AI. So do you use some kind of machine learning with metrics?
I do not.
We do have some machine learning, but we try to not make it automatic. Like we do have a product where you can say, hey, run these algorithms on these metrics and kind of show the trends, and then you can alert on the trends and the deviations from the trends. But we try to make this manual so that developers think and know what they're doing when they set up that alert. I think it's really hard for machine learning to get all the edge cases correctly, and you might end up in a case, it's very common that you miss the important alerts, or you get a lot of alerts, so you black hole everything and then you miss everything. So yeah, we do some machine learning, but we haven't found like a magic bullet. I don't think it's possible to find a magic bullet with our complicated architectures and applications. So if you're doing machine learning, that's a good thing, but think about what you want to achieve and then use machine learning to achieve that, instead of being like, hey, AI, just alert on anomalies that you think are anomalies. That will just end badly.
Yeah, well, we do have a tool in our portfolio. I don't want to talk about that tool, but yeah, I think this is really the future that we are going to look at in observability, the machine learning. Some call it AI, because this is really about searching the needle in the haystack. You cannot really pick everything from the screens, no matter how well consolidated, how well correlated the stuff is. Simply, there's so many things happening, and there's so many symptoms associated with a single failure. So the root cause is perhaps one, but there's lots of indicators on that. So we definitely need some AI, some machine learning. I agree, it is a complex area. We do have solutions for machine learning, on logs, also on metrics, but this is pretty hard. Yeah, this is really rocket science almost, and yeah, and it depends on the customer, their use cases. So no matter, we may develop, we do have generic models for many typical scenarios, typical situations, but still you will have lots of customer-specific cases. So basically, I think we are looking at some tooling that will provide some general-purpose AI machinery that will sit on top of the observability tools or platforms. Maybe that's the future.
If I may, I'm not an AI expert, but we are having these active discussions on this theme about how to connect these areas. And we see a couple of challenges, and one of the challenges is a problem of training. So you can have enough training data from the system you are running, but that data needs to be you need to create a trained model, and in order for the model to be good, you need to look back on certain amount of time. So therefore, that means that you need to train that with the data that are going long back in the history, which means you are supposed to be spending a lot of money on that training, and it's kind of hard to justify the expense of running the continuous trainings, potentially very expensive big machines, versus the assumed benefit of the thing. So it is kind of, I would say that at this stage, it is excellent solution looking for a good problem. So,
I also just want to add to his point. I think there's a lot of value AI can add. I just wouldn't run your primary alerting on top of AI. I would still run primary alerting on top of SLOs, and once you get alerted, then maybe you can look at AI for possible causes to this. That can maybe then start to, okay, what is the anomaly compared to last week, and why did this alert fire? That could be something that's useful. And you might not even need AI, but it could look AI like, for example, all you need is like a history of all the alerts that fired, all the incidents that happened. And when an alert fires, you could basically look through that history and be like, the last time this alert fired, these incidents were declared and these were the root causes. Can you check these? That is also AI for most companies. Yeah, you don't need AI, but like you can get a lot of things without AI, but do not run primary alerting on top of AI, please. It just sets you up for failure, yeah.
I just have one observation that since I started university way back in the late 90s, they were promising us that AI was going to be solving all the medical systems and automating all this stuff. And what's the biggest innovation that we are hearing about right now is just ChatGPT, you know? That's all I'm going to say about that.
Okay, thank you. And another one we have, how do you handle FinOps?
Well, I touched a little bit on it with a stat, but there's quite a bit of stuff that's come out in the last 6 months around this, and there are organizations you can find online, like LinkedIn and stuff, that have FinOps, like practices and things like that. I know in North America they're quite heavy in that. I was reading an article yesterday about someone that was interacting with Google and just launched something around some FinOps programs. So you would be pretty hard pressed not to be able to find enough information if you dig around online a little bit about this and maybe join one of the local meetups if possible in your area.
At Grafana, we do have like a cost optimization team, which is similar to FinOps. And we're just building on top of open source tooling out there. So there's OpenCost, which is a CNCF project. You deploy it onto Kubernetes, and it'll tell you this namespace is costing you these many dollars. And that's pretty good already. And it'll tell you this is the amount of utilization that you're running at, 80% CPU and things like that. But yeah, I would, we are handling it by having a FinOps team and using open source projects.
Just a quick one. Well, in a similar way, we also have attempts in this area to optimize the costs, either on-premise or in the clouds. But I think there's an important connection to observability, and it's the term that is sometimes used. It's right sizing. So you can definitely leverage observability to give you the inputs to correctly size your infrastructure, your virtual machines, your pods, your Kubernetes clusters, etc. Because you probably know it better than me, and that it's always a problem to size the cluster, to size the pods right. You never know upfront in advance what will be the correct sizing. So observability, there's a very, very tight connection to the FinOps aspect of it, like managing costs by right sizing the workloads so that you don't overdo it and also don't, underdo it so that you have underperformance. So you don't want to spend more than you have to.
For FinOps, it depends what you wanted to calculate it. If it's the spend of the cloud, about the network, about the Kubernetes. Yeah, because there are some solutions for the Kubernetes, so it was mentioned, the OpenCost. There are also some, if you are using the managed Kubernetes cluster, so there are some solutions, for example, by the Google. Yeah, and it works somehow good, except PVCs, of course. But, it's not just about the Kubernetes, because you wanted to calculate the whole infrastructure and also maybe split it by the application. But sometimes it's if we are in the Kubernetes space, right? So the application doesn't mean that it's run on the one namespace. So how you will calculate it? Because these tools are based, for example, by the namespace or some tags, right? So yeah, the current solution, they are not, I think, final. I hope so, because we miss there a lot of information. Yeah. But when we speak about the cloud solution, I think that it's provided by your cloud provider.
I'm not directly involved with that group, but what I know is that we are using predominantly the SaaS solution and the partner solutions for that. It's something like Cloud Checker that gives you information about which parts of the which accounts are underutilized, and also now the Kubernetes is deploying some solutions. They are using Spot, which is essentially trying to utilize the Spot capacity of Amazon Cloud. These are the two that run on the top of my mind. But generally, if you are running Kubernetes in a multi-tenant mode, then cost distribution is a non-trivial problem, because it is if you have everything split by the namespaces, then it's relatively easy. Most of the tool gives you cost allocation based on namespaces, but if you are sharing infrastructure for multiple tenants, then it is not an obvious which portion of the cost belongs to whom. Obviously, you could run one Kubernetes cluster per customer, or even one Amazon account per customer, which makes it extremely easy to calculate, but it's not the most efficient way how to do things.
Thank GraphQL, and you started to mentioning some tools, so I will also grab the question about that, like how important is having like really unified view when it comes to observability, and what tools you can use.
We actually have a talk that we shared. It's called Single Pane of Glass, and they spell pane P-A-I-N. Right? I think when you look at an organization, the complexities that you're dealing with across the organization, depending upon who you ask in your organization, what's important to them, is pretty much representative of the view they want to have of what's happening with the business, right? And so I think a single pane of glass is a complete fantasy. I don't think it's ever been successful anywhere. I don't think it's ever stayed with just one view. I'm not saying you don't have that single top tier, whatever you try to look at your business with big green, red, and yellow boxes, but it's pretty much a sad attempt at saying what the status of the business is at that moment. It requires all these different layers for a reason, and there's nothing wrong with that. Do you agree?
That's a good question. So before I get into the tool, I kind of want to go back to the story I told about traces and how I implemented traces. This was before Loki was there, before Grafana did logging or tracing. So the way we did this is basically take all the Kubernetes logs, pipe them into a file, run a script which gets the trace IDs and the slow queries and all of that into a Google spreadsheet, and then sort the Google spreadsheet by the slowest queries, and then look at the trace IDs and then open them in Jaeger UI. Now you can imagine how painful that was, but before that we had nothing, so that was the greatest thing I could have built as a junior engineer, and people loved me for it. Now, again, this is how we kind of learned, okay, people want metrics to logs to traces in the same, in an easy way to jump between the three, because they give you three different kinds of insights that you will be using together to solve problems. And there are many tools that kind of give all that insights in one place. Like if you take Datadog or New Relic and other observability SaaS vendors, all of them are in the same place, and you are able to jump from A to B to C. And I think that's quite important. You can obviously, if you want to do it with open source, you can do that with Grafana. And this is also something that we are seeing, as Eric said, like, if you take a large organization, it's really hard to get all the data in one place. There will be 5 different monitoring vendors, 5 different logging vendors, and trying to get them into the same place is really hard. And trying to do that longer term, you can do that with Grafana, but you wouldn't be too successful, because when you're trying to interact with Splunk data, the best place to interact with Splunk data is the Splunk UI. You can put Splunk data in Grafana, and it will give you a beautiful view. But the moment you try to deep dive and debug, the powerfulness kind of reduces. And that's for a lot of people, that's still better than the workflow that I had, which is like, you go from here to another tool, to another tool, to another tool, and it takes me 20 minutes to get the insights versus the 5 minutes. So it's a question of trade-off of how much power you want, versus how quickly you want to get from tool A to tool B. Yeah.
Again, a quick one for me. I agree. Everything, screens are important, and I think this is also a place for the future consolidation of the tools. So again, if you are talking about the future of observability, this is the area that will take place inevitably. Another comment regarding the availability of data. I think it's really crucial. You can have good screens, but is it really that you're looking at the screens all the time? Wouldn't you rather prefer to have the right information at the right time, where you need it, at the right context? So first thing, I think users will appreciate tools that give them the context not necessarily by looking at graph, but maybe clicking in the right place in the graph, topology, showing things in context, and clicking, drilling down in a connected way. That's one thing. Another perspective here is that there are alternative ways to screens. For example, there's a concept of so-called chat ops. I don't know if you're familiar with that, but some people, who are crazy about chat platforms like internal Slack, if you're heavily committed to this, if you use it internally, it may be a good idea to connect your observability tools to Slack and have the insights being presented to you as Slack messages with all the insights, with all the correlated content available there as the first contact for you, and then you can extend your analysis to getting to the full-blown dashboards or to the screens.
If I may add, I wouldn't see it as having unified view from an operations perspective, because if the action of the result of having that view is actionability, then with a large enough organization, you have always different teams for different systems with different skills, and the team that is managing your Azure cloud doesn't actually care about any alerts from Amazon and vice versa. So this is just distraction for them. So having unified view is actually worse. What you may want as a unified are some sort of reports for the decision makers that are not essentially to be doing something about that result, but using that data in order to plan and in order to make a decision, so for like decision support system. And in this case, it's important to have unified view, but it can be done significantly cheaper and significantly less obtrusive way as to force the whole organization to use the same tool chain just in order to have one unified view of the data.
No. What's quite common is that if you force more departments to use one tool, so they try to modify it for themselves, in a bad way. I saw it so many times. So the thing is that one way is just force them to use some SaaS solution like Datadog, New Relic, and stuff like that. I have some experience with that, and I understand that it's useful for someone. But when you wanted to do this, modification, so maybe you realize that it's not the way. Yeah? Another thing is that the vendor lock is also not the best way. So it's much easier to choose some tools from the CNCF landscape and try to connect them somehow, because there are more solutions how you can do that. So.
And when you mentioned the bad ways to using it, so can you maybe tell us more of this? Maybe we can learn even from the not best practices, but what went wrong and how we can learn from it.
Oh, you just teed that one up. So what would be bad practices? We've already pointed out putting in ML and AI up front, trying to put a unified view in place. What else would be good? Choosing as many tools as you can come up with that they'll let you buy. No, but all the joking aside, I think the worst practices that are going on right now, and what people fail to understand, is the amount of data that is flooding into your organizations, being collected, it's being stored, is what's running those costs up, right? We've already covered that. But being able to find a way to corral that is immensely difficult, in organizations that have gone down different paths like we've been talking about. You may end up having one or two of those problems in your org right now. What you're looking for is some kind of control plane between you and what's coming in before it gets persisted, so that you can see what's not being touched, what's not being looked at by a user, which is not being used in a dashboard, which is not being used in an ad hoc query, which has absolutely no impact on anything you're doing at this moment in the company. Those kind of things you want to be able to block at the door. You're not getting rid of them. You're not, throwing them on the floor. You're just not using them right now. And you can flip the switch and turn that back on later if you need them in a new project and define that I need those labels or I want these metrics or whatever the deal is. The second thing is, I think it's really important not to get too fixated on tools and all this other stuff. It's mostly about trying to figure out what your business is doing, what when you design your visualization, whoever's the business behind you having to design that visualization to keep track of what they're doing, they know best what they want and what they need. You just have to have the ability to narrow down and only use what they need and not pay for one penny more or one label more or one sub-dimension more of any of your metrics. Right, that's such a strict policy. You need to get set up as soon as you can, because it'll snowball out of control in no time, and it just gets exponentially worse when you get successful in a cloud native space.
One example from my experience, things that can go wrong is, an example one is a customer who has a lot of legacy, so it's about the right tool for the for the right software, for the right system. So I think it's wrong if you approach to replace an existing monitoring solution which has been working for ages with some sexy new observability platform which does tracing all the metrics, and actually basically have to force the customer to redo all their all the setup in order to be able to consume Prometheus metrics and so on. So I've seen enough such attempts. I can't say really that I have seen like disasters happening. I think that it didn't actually come to the disaster level yet, but I have seen so many attempts trying to force potential customers to new tools that they are not ready for.
I would add to these not so brilliant ideas. Kind of one idea is to using multiple delivery channels for notification. Like you post message into multiple Slack channels and send an Ops Genie notification and an email just in case, which will essentially make sure that your team will be dealing with the same thing 3 or more times and lose a lot of times. This is kind of one of those ideas. The other is that you define very loose response groups or escalation levels, which means that everybody knows that everybody else has also got this notification and everybody assumes that somebody will take care of it. So in which case you will end up with much longer response time, as if you know that, well, it is my responsibility today, and if the next escalation is this guy, and that this way things will happen. But if there is a large group supposed to be taking, then it either generates a lot of unnecessary communication, who is taking care of that using a different channel, or just people just assume, okay, somebody will take care of that. That's the...
I see two of them. First is sending too much alerts. That it happened that the developers and also ops team just stop focusing on it. Yeah, because they realize that, okay, there is something, I know it, and it's quite common. So, and the second thing is what I mentioned in the beginning of the talk is storing data which you never used, and also store a precision of the data which is not necessary. For example, if you collect every second, the metrics, so maybe it doesn't make sense for all of your metrics. So you just pay for storage what you never used.
A couple of things that I see in large organizations is like centralized firefighting teams. So you write an alert, but the alert gets routed to a central team, and then they triage it, and then they assign it to the right team. That is just a bad position to be in, but it's also quite common. This is what SRE teams are there for in some companies. The other issues I see is you have the data, but you don't have access to the data. For example, you could be on call, and your data could be in Splunk, but you don't have access to Splunk. You need to talk to a different team to get access to Splunk for an hour, and this is also quite common. So just make sure if you write an alert, it gets to you and not someone else. And if you're on call, if you're collecting data, you have access to the data at the right time, at the right place. Yeah.
That just triggered something really quickly I wanted to mention too that I saw last that I was pretty impressed with when I saw it was designing dashboards to include all the links and help and stuff you need from that point. So no matter how experienced you are, you're being led down the same path as an experienced person would do. So that's part of the understanding what happened last time and then putting something together that's available to immediately deal with the same problem again. And I thought that was pretty neat when I saw that all integrated into the dashboards they're monitoring anyway. It's really a nice touch.
And I will go to one more question, and then we will need to finish. So Alexei is asking, is it reasonable to set up traces for the monolith?
Yes, it's called an APM. This is like before distributed systems, cloud native, whatever, tracing existed in the form of APM. It traces like all the important function calls, how long a request took in each function call, and I think that's highly useful information. If a request is taking 5 seconds, you want to know where are these 5 seconds happening, and I think traces are a really, really good way of answering that. And yeah, it's quite useful.
And to understand that, it sounds like somebody might not have fully understood the difference between a monolith and a cloud-native environment where people took old monoliths and broke them up into microservices, so a bunch of little services, where then when we talk about tracing, it makes a lot of sense because a call goes off into the wild and we don't know where it went. And the next time you do the call, it takes a completely different path through that sea of microservices. So finding out what went wrong and why it went wrong and where it went wrong becomes really, really important in those spaces. Whereas in APM, like he's saying, it's more function inside of the programming language classes. You kind of it's almost like debugging in your IDE, I would say, but then live.
Oh, yeah, profiling, yeah.
Yeah.
On a per request level. I wanted to mention
There is also one aspect of monolith that, okay, let's assume that your traces will reveal something. Now, for you, in order to fix it in code, means to do a full release. Which with the microservices, you can do this kind of, you replace just one microservice and there is much less disturbance. So essentially, your ability to act upon discovery of something important is very different from the microservices. So I would say it is also important to put traces around the monolith, because quite often the situation is not that the monolith has a problem, but something that is around it, something in the environment changed, and suddenly the communication doesn't work. And if you are putting traces around on all the endpoints that the monolith talks to, you may find out that all you have to do is just simply to restart restart one of the services, and you are fine. So it's a slightly different situation to the cloud native, but yeah, I agree what was said on that.
And exactly for strict monoliths, like a single binary, we have profiles, right? That's the analogy for traces. Profiles and stack traces. One thing regarding microservices, and tracing that we see today, there have been architectures before. And I think we still call them monoliths. Those were called in the past like distributed architectures, like SOA, service-oriented architectures. I think they still qualify as monolith in a way. And what I want to say is that there was tracing before. We didn't call it tracing. We call it distributed monitoring, which evolved into tracing that we know today. So this is not a new concept. So if you have in mind like those classical three-tier architectures and some service bus around, all the legacy stuff, there has been tracing before, only a little bit, a little bit more difficult to work with.
Yeah, I just wanted to mention that if you like syscalls, so of course you can use some solution for continuous profiling, like Porco, I think it's in CNCF landscape. But maybe you are the lucky one if you can read it, I mean, from the developer's perspective.
Andrew Tannenbaum. He's an author of those famous operating system textbook and the author of Minix that inspired Linux and so on. It's it was one of the celebrities when I was going to university. He once said the definition of the truly distributed system is that is the system where a failure of a component that you didn't know it existed can cause the non-functioning of the whole system.
Thank you all. And we are running quite out of time. So I would like to just wrap up the discussion maybe with one question. Where do you see the future of observability and some kind of emerging trends and technologies in the future?
I will be quick. I hope that in future there will be something like no ops. That I hope that one day there will be AI that will can handle more of the stuff. I don't think so. I mean, in the near future, but I hope that it's the future.
ChatGPT. No, just kidding. Again, I agree with the no-op stuff. With eBPF, it's super promising. Like you just focus on your business logic and you drop an agent in the kernel and you get full insights into your application at the granularity that you want without affecting performance. I think that's utopia. And I think we're very, very close to that. Yeah.
GPT or AI ops, AI-enabled monitoring. This is the future for sure. I think we haven't mentioned the aspect of security. I think this is becoming even more relevant recently. So security should be really a dimension in the whole observability discussion. So maybe a topic for next time.
I really don't have anything more to add, and I can say that I certainly hope it will be somebody else's problem, and that observability and all those SRE will go the way how serverless was kind of continuation of the classic servers. So essentially something that scales on its own, runs on its own, and it's essentially no ops, as Zdeněk said.
And I think it's a little bit more positive than that. I think the future is now. I think these third generation parties that are outsourcing the observability into the cloud and having the ability to put some kind of control plane between you and your ingested data and give you control back and give you the chance to decide what's important to you and you to decide how to limit your bill is just fundamentally more important right now to everybody. Than all these other little things coming down the road in the research spaces. I think you're going to see a lot more interest in these kind of solutions and these kind of takes on observability, giving you the control over your own environment. And thank you very much.
Thank you, everyone. It was a great panel. Thank you for all the questions from the audience. You were very engaging and helped me with running the discussion. And I hope that you will continue in it after this session, as we will have a coffee break, and you can get together with the speakers and ask them some follow-up questions. So thank you so much, and thank you all.